Okay, in the similarity-based contextual model, there are three representations. The first is independent context similarity, or ICS. The other is latent context similarity, and the last one is multi-dimensional context similarity. So, for example, this is an example. If I have the context C1 and dimension 1 is weekend and the dimension 2 is location is at home, okay, and the context C2 is weekday and cinema, like this. And I know that the similarity is, for example, 0.5 and 0.1. Okay. If we calculate the, this symbol, this is the multiplication. If you use the sigma like this, so it is summation. Okay. This symbol means product or the multiplication. Then we want to multiply for all the similarity. This is from the index 1 until n, and we have the similarity of dimension 1 is 0.5, the similarity of the dimension 2 is 0.1, and then we have the similarity is 0.05. So this is the overall similarity between the context C1 and the context C2. So this is the idea of ICS. ICS is the independent context similarity. So we just calculate the similarity value. The independent, it means sometimes we can look at only on the particular time, but no information about the location. Or sometimes we have the information about only location, but we do not have the value anything about the time. Okay. So this is just a general similarity. In this case, if there is no such kind of information, what happened? There is a kind of missing information and it will be 0. Okay. If it is 0, then we cannot have this kind of similarity measures. So it is the limitation of this independent contextual similarity. So we need to assume that every possible contexts are available. If not available like this one, there might be some 0. The other kind of similarity, we call it latent context similarity. Latent. What is latent? Latent is something that high level features. The high level features means you need to extract some features, and from the features we can have a high dimensional value. Usually we just represent, for example, the F1, F2, and so on for the high level features. Let's say in this case, I have home. So at home, we can have some additional features or high level features, and we can represent it in the factor. So this is the factor representation. If I have the information at home, for example, at home, I can have the feature of area. Okay, so this is more visible or something that you can get the information. What is the area when you watch a movie? For example, you watch a movie in a particular room or in the living room, and the area is like 20 meter square. So we can have the features, the area that you watch the movie. Or you can have another dimension. Where is your home location? For example, the home location is in the apartment or jutek or something, and so on. So we can also have the same features for every possible location. For example, I watched the movie at the office, workplace. It means I can also know what is the area of the office. So how big is the size of the office? What is the location of the office? The cinema, we can also have the idea what is the area of the cinema, and then where is the location of the cinema, and so on. Okay. So there might be more additional features. So these high level features can be the interpretable features, or we call this is more obvious features, just the variable, or something that is latent. The latent means something which is you need to have computation. So if you need the computation means you will use something like the matrix factorization and etc. If we have these features, then you can calculate the similarity. Okay, how can you calculate the similarity? You know the partial correlation. You know the cosine similarity. So you can just do the difference and then calculate for every possible value. And you will know the similarity between home and work. It means, we can look at a particular combination. For example, I want to calculate the similarity between home and cinema. So I will calculate the home and cinema, and then I calculate the similarity between work and cinema. And then in the testing, I would like to use the similarity of home and work. So we can make something like the cross validation. If the training now is home cinema, work cinema, and the testing is home and work, and in the next round we can change the home cinema and home work for the training and work cinema for the testing, and so on. The same with the ICS or the independent context simulating. We can do the product. This product means the multiplication. Again, using this method, we need to assume that every value are available. If one value is not available, it is 0. Then the similarity value will be 0. Any value multiplied by 0, it will be 0. There is another kind of context similarity. We call it the multi-dimensional context similarity, or MCS. In the MCS, we want to check the similarity based on the variable. For example, this is location, this is the variable companion, and this is the variable time. And for every value, we will put it into a number. For example, okay, if the location is at home, I put it into the value 1. So 0, 0, 1. It means the companion is 0, the time is 0, and the value of home is 1. If it is cinema, so I put more value, 4. The other is 0. If I have the companion, maybe this is about the movie. I watch the movie with kids. Okay, so 0, it means the location is 0 in this case. And then another 0 is the time. And then I put a value 2 if we go with kids. If I go with family, the value is small. It is 6. If it is on weekend, the value is 5. If it is on weekday, the value is 2.5. So the other is 0, 0, 0. Then let's say you want to measure the similarity of a particular context. I want to know if in this case, I want to know if it is kids, okay, and home. And then we have not available. In this case, we can see what is kids. The kids is 0, 2, 0. And then what is home? Home, we have 0, 0, 1. Okay, then we have a value, or we can just have 2, 0, 2, and 1. For example, if we have another NA home weekday, then we have a value of home, it is 0, 0, 1 plus weekday 2.5, 0, 0. Then we have 2.5, 0, 1. Can you measure the similarity? Because we have the value. So the similarity between the context kids home not available and the similarity and NA home and weekday will be based on this value and this value. So we have the, for example, using the cosine similarity, then you can choose to just do the calculation with cosine. If you want to do with the person similarity, you can do with the person similarity. Okay. Or if you do not want to use the similarity, you can measure with the distance. So in the distance, we can use the Euclidean distance, we can use the Manhattan distance, and so on. So the other challenges when we do with the context recommendation system. Numerical versus the categorical context information. Another challenge is about the cold start problems and how you can explain. This is another issue. And how you can define the interface and how you can have the interaction with the users. Some more application and what is the recommendation opportunities. For example, if the categorical context is the time is in the morning, the time is in the evening, the time is on the weekend, the time is on the weekday. But how about if the time is numerical context? The time is at 6:30 p.m. So this is challenging. How you can convert this one into a particular category? Or for example, I watched the movie in between 2 until 6 p.m. Because of the privacy issue, the users, they didn't want to tell you the time. So there are many issues with the time-aware recommendation system. For example, the location. Okay? Location is also a categorical. Home, cinema, work, party. In some cases, people do not want to share the name, but they want to share only the latitude and longitude. Do you know this one? Chua-Piu? Yeah. So in the Earth, we have the longitude and latitude. Because we know from the smartphone, if we detect the GPS location, then it is automatically, we can get the data. However, it is numerical. We can also have the categorical, like companion, family, kid, partner, and etc. But yeah, if it is numerical, maybe it is not possible with numerical. However, we can have more information. How many family members go with you? Maybe in Indonesia, if we watch movie, sometimes we watch movie with many family members. Some family members, they have 7 kids. Okay. Then it means they will go to movie with 9 family members. The husband, the wife, and the 7 kids. Okay. So if we have more values, this one. The kid, okay, so it's always on the kid, okay, or partners, okay, if you just go with you're judging, not judging, then it's only one person. Or sometimes you have another information like temperature. This is numerical. You watch movie in the temperature 12 or in the temperature 38. It can be also another information. Sometimes we need to use some dimensionality reduction like PCA. If we have another numerical values, so how we can develop cars? Okay, so do you still remember cars? Cars is the context aware recommendation system. Okay. So there are many issues in the context aware recommendation system. And I guess many of your papers, many of your research paper that you will present, it is related with the context aware. So that's why when you present, please try to find the correlation with the material that I shared to you. Because last time I mentioned to you, please mention for every possible correlation with the material that I explained with your paper. And cold start. I think you still remember the meaning by cold start. When the cold start related to user means there is no rating history by this user. If it is cold start by the item, it means no rating history on that particular item because it is a new item. There might be some cold start on the context. So no rating history within this context. So maybe the cinema is new, or you just married. Then no information about going to a movie with your wife, going to a movie with your husband. So there is no information. Then it is a cold start. Some researchers try to use the hybrid method. There is another kind of challenges, how to explain. For example, the recommendation using the social network. How can we know that you watch the movie because of your friend? There are some research that the improvement is not significant. It means the recommendation based on the social network is not that significant. Unless we explicitly explain it to the end users. So, explain. What does it mean? For example, you watch a movie, and then when you want to recommend to another friends or another person, you explain it first. This movie is good. This movie is very interesting, or this movie is very blah blah blah. So by using that explanation, then the user might be interested to watch that movie. So using the rating itself is not that significant. Recommendation using context. So it's still open research. Similar thing could happen in the context aware, and how to use context to explain recommendation, how to design new user interface to explain. So the other thing is about just the user interface, how to collect context. It is also a challenge. So as I mentioned to you, for the data collection, people do not want to share their location. So they just want to share their coordinate. Then you need to get what is this meaning of the coordinate. User need to interact with the user interface nicely and smoothly, and it is complicated. The user interface need to explain the context-aware recommendation clearly, and it should avoid debates on the user privacy. And this one is also about the collection and the usage. So that's why whenever you have a new membership in the online nowadays, you need to agree. Sangin. And nowadays there are many demands on this new application. Not only the e-commerce, not only the movie, not only music. Okay. So on some of your papers, you have the recommendation on job. Okay, so let's see about the job recommendation. And I think some of you may present about fashion recommendation. So it is also another kind of new domain. Okay? It's very interesting. And now I'm also working with my colleague in Indonesia. We want to have a route recommendation. In Korea, I think it's also the same. There are many traffic. Okay? So if the traffic is very complex, there are many traffic jam, for example, then we can recommend another way to make the time lesser than the original time. So we call this is the route recommendation. It is also applied to the tourism. Yeah, we can make the trip planner, we can analyze the traffic and the planner. MOOC, do you know? MOOC. This is the online learning, massive open online course. Yeah. So it is the online learning via different characteristics. So you can join like the Coursera. I think in Korea also there are many course online, and you can recommend what is the best for you. Lifelong. So the digital health, all daily activity tracker. This is also a new approach. And the shared economy, Uber, Airbnb, and etc. Okay, that's what we learned until now about the context aware. So we learned about the definition, and then how we can collect the context, how we select the relevant context. And then I mentioned two algorithms, context filtering and the context modeling. Okay, any questions? No question, then I will continue with the next section.